Welcome dear students, welcome to online support program. I hope you are all fine and enjoying online support program. I am Miss Arooba Farooq from F6 Gujranwala Cantt with the lecture of week 5 of grade 6 science. You all know that the holy month of Ramadan has been started. Ramadan is a month of Allah, start is mercy, the center of whose is forgiveness. The end is freedom from fire. Ramadan Mubarak to you and your family. Have a blessed Ramadan. May Allah bring you more blessings this Ramadan. As we have started this chapter in week 4 and in week 5, we still continue this chapter. Before starting our today's lecture, let's have a recap of week 4. In previous weeks, most of the students have done a wonderful job. You have done your work very nicely and uploaded. Your assignments and quiz were very good. Well done, my students. Keep it up. In previous week, you have learned about particle and matter. Particle are tiny bits of matter, and there are three states of matter: solid, liquid and gas. Solid have definite shape and volume. Liquid don't have definite shape but it has definite volume. Gases don't have definite shape and volume. Learning objectives. Students will be able to learn in this week evidence for particle model on page 34 to 36, in which included evidence that particle exists, evidence that particles are always moving, more evidence that particles are moving, evidence for the spaces between molecules, expansion and contraction on page number 37. Evidence for particle model. Evidence for particle model. Although we can't see individual atoms and molecules in solids, liquids and gases, there is a lot of evidence to support the particle model. Everything around us is made up of tiny particles. The particles which make up matter are atoms and molecules. The evidence for the existence of particles in matter and their motion comes from experiments on diffusion and Brownian motion. And there is very interesting information. A small drop contains about 10 into 20 power particles of water. It's very interesting. Evidence that particles exist. Have you ever noticed how a balloon always goes down after a while? No matter how tightly the balloon is tied, the air inside always seems to escape. This is because the skin of the balloons has millions of tiny holes in it. The molecules in air are small enough to pass through these holes, and so the balloon deflates. Now there is a question. Explain why a balloon slowly deflates. Yes, the skin of the balloon has millions of tiny holes in it. That's why the molecules in air are small enough to pass through these holes, and so the balloon deflates slowly. Now there is another question. Explain why a balloon deflates quickly when you stick a pin in it. When a pin is stuck in an inflated balloon, it deflates quickly because a larger hole has been made through which the gas particles escape. Now, evidence that particles are always moving. Let us understand that how particles of matter are constantly moving. With the help of diffusion and Brownian motion, we can prove that particles of matter are constantly moving. Now, diffusion. What is diffusion? Diffusion is the movement of a substance from an area of high concentration to an area of low concentration. Basically, diffusion happens in liquids and gases because their particles move randomly from place to place. I said diffusion happens in liquids and gases. Now there is a question suggest why diffusion does not happen in solids. Can you give answer? Because the particles in solids are held together by strong forces of attraction. Although the particles vibrate, they are unable to break free. And diffusion is spreading of one substance through another. Now there is an example. The beaker contains water. A drop of ink has been put carefully in the center of water. The ink particles gradually diffuse outwards to mix completely with the water molecules. Now, another example of diffusion is bottle of perfume. When you take off the cap, the smell gradually spreads out. Now there is a video about diffusion. I hope you will understand better. Can you paint my picture, please? Now, Brownian motion. Brownian motion is the random motion of particles in a liquid or a gas. The motion is caused by fast moving atoms or molecules that hit the particles. Brownian motion was discovered in 1827 by the botanist Robert Brown. Robert Brown noticed that pollen grains moved jerkily when placed in water. In this case, the tiny pollen grains were being bombarded by moving water molecules. And the best example of Brownian motion is a moving bee. I hope you have clear concept about evidence that particles are always moving. Now there is a video about Brownian motion.
Brownian motion. The first evidence that matter consists of tiny particles in motion was given by the English botanist Robert Brown. When Robert Brown was studying the pollen grains suspended in a liquid using a microscope, he discovered that pollen grains were dancing to and fro in a random manner. Similar haphazard motion can also be observed when small colloidal particles suspended in a liquid are examined under a powerful microscope. The zigzag motion is due to unequal bombardment between the suspended particles and the molecules of the surrounding medium. This irregular motion of suspended particles is referred to as Brownian motion. We shall now study movements of large and small particles suspended in liquids. Let us first look at an isolated large particle A suspended in a solution. A number of molecules hit particle A from all sides. On an average, the impact mutually cancels out. So, the resultant force on the particle is zero. Now, observe the particle B, which is very small. Particle B is hit by less number of molecules. Moreover, it is not hit equally from all sides. Due to this, there is a resultant force. This resultant force alters the direction of particle B. When particle B moves, the direction of the resultant force also changes, resulting in a zigzag motion. Let us now understand Brownian motion with the help of an experiment. Fill a hollow glass cube with smoke particles. Place it under a low-power microscope. Simultaneously, illuminate the cube with a light source. We observe that the smoke particles appear as bright particles moving in all possible directions, in contrast to the black background. This is an experimental evidence of molecular motion or Brownian motion.
I hope you will understand about diffusion and Brownian motion. Now next topic, evidence for the spaces between molecules, we will discuss in the next video.